We're asked to write the standard matrix or transformation matrix for an R2 to R2 linear transformation that rotates points 2/3 pi radians about the origin. When we have an R2 to R2 linear transformation, the first column of the 2 by 2 transformation matrix is equal to the transformation of the vector E sub 1, or the vector 1, 0, and the second column is a transformation of the vector E sub 2 with the vector 1, 0. So let's see if we can determine the transformation of the vector E sub 1, which again is a transformation of the vector 1, 0. Let's also determine the transformation of the vector E sub 2, which is equal to the transformation of the vector 0, 1. And now if we look at the unit circle on the right, I've already graphed the vector E sub 1, or the vector 1, 0. And now to find the image of this vector under the transformation, we will rotate this vector 2/3 pi radians, or 120 degrees, counterclockwise, which means the image of the vector E sub 1 under this transformation is this blue vector here. And because we're on the unit circle, we know the vector is negative 1/2 square root 3 divided by 2. And now let's find the transformation of the vector E sub 2, which is the vector graphed here in red, the vector 0, 1. To find the image of this vector under the transformation, we rotate the vector E sub 2 2/3 pi radians, or 120 degrees, counterclockwise. The transformation of the vector E sub 2 is this blue vector here. And again, because we're on the unit circle, we know this vector is negative square root 3 divided by 2, negative 1/2. This is the information we need to find the transformation matrix or standard matrix for this linear transformation. Again, the first column is a transformation of the vector E sub 1, which is negative 1/2 square root 3 divided by 2. And the second column is a transformation of the vector E sub 2, which is negative square root 3 divided by 2, negative 1/2. I do want to compare this result to the following transformation matrix shown below, where we're given the following transformation matrix rotates vectors or points counterclockwise in R2 by an angle of theta. So this is the general form of the transformation matrix for any rotation in R2. Let's verify we get the same result using this transformation matrix. Let's find the cosine of 2/3 pi, the sine of 2/3 pi, and also the opposite of sine 2/3 pi. We can just use a unit circle here. The cosine of 2/3 pi is equal to x on the unit circle. Cosine 2/3 pi is negative 1/2. And sine 2/3 pi is equal to the y-coordinate of square root 3 divided by 2. Of course, the opposite of sine 2/3 pi is equal to negative square root 3 divided by 2. So using the formula shown here below, cosine 2/3 pi is negative 1/2, which is the entry in row 1, column 1, and row 2, column 2. The entry in row 2, column 1 is sine 2/3 pi, which is square root 3 divided by 2. And finally, the entry in row 1, column 2 is negative sine 2/3 pi, which is negative square root 3 divided by 2. And of course, we get the same result. I hope you found this helpful.